Earlier this year in the city of Stevens Point, we had some significant flooding. We escaped the bullet, but I'm just sharing some footage here of both the downstream and the upstream conditions. On the bottom right is the city or the river in full surcharge, and on the other three are places where the water is flowing back from the river to an intersection located at Pat Street and Michigan. So the proverbial blowing the manhole covers off worked a little bit differently here. You can see a footbridge there on the bottom, or I'm sorry, a water pipe bridge, as well as an old railroad trestle, and you can see how surcharged the river was, and tie some elevations back to that. You see an underpass
going now across the street.
Condition.
You can really see that idea of manhole covers being popped up.
Remember to learn your basics of Bernoulli's, your units, and then apply the tools you have to manage conditions like this so they don't get out of hand.
That is pretty some severe bypass. Water's flowing so quickly around that curve, right? And you can see that even in a normal drainage situation, the water's going down to the bottom anyway, but that's not going to make it into the pipe. Same thing on that side. And those are kind of small grates, but even if small inlet grates, but in fact, even if they were larger, they wouldn't catch much more. At this point, you get average inflow minus average outflow times delta time equals storage, delta storage. And this is a great one right here to kind of come out to and model. And I'll try to come out over the day here. They're pumping out with a certain size pump. It's not going to keep up. We'll see how high that rises. Once again, average inflow minus average outflow over time. Times time gets you change in storage. Storage generates for you an input for a storage elevation curve.